Good morning, good evening, good whatever, uh, and welcome to the stream. Um, so, uh, During this stream here, I'll try to implement a system for drawing lines. Since it's part of the old project, it will be fairly easy to do. The thing is that during the last episode, we implemented the whole calculation of the bounding volumes, for our objects. And we basically got most of the pieces that we need to actually start creating a quote-unquote game. Of course, there will be a lot of different methods for the backend that we haven't implemented yet, that we need to implement to actually make the game, but we'll figure that out as we go. Okay, so yeah, we need some debugging utilities for drawing lines, and we need some GUI and backend stuff um, in order to do that. During the last episode, I was contemplating whether to store the original center, since it will give us a bit of speed when we translate the uh, bounding volumes, since we can simply just multiply the original position with the translation part of the transform matrix. Um, yeah, we'll try that out. Maybe we don't need it. But either way, we will store it. Also in the yeah, okay. But anyway, we need um, a pipeline state for rendering lines, and I'll of course grab it from my other project. Let's do a line pipeline. And let me just check what I used to do. I changed a bit of the code, so we will probably have to do some adjustments. But so during initialization, we do some stuff. Okay, here we set up the polygon pipeline. And we have to clear the pipeline inputs. And then we want something like this. And we want something like this, but we change the name. And we need to create some shaders, lines, and we need, let's just jump into the folder. Let me copy the other stuff and edit it really quick. Let's do a void. It's not certain that everything compiles, but we will start by creating this return float for. There we go. At least we'll start by doing that. Okay. And let's see. We should probably mirror this so inside the not the polygon one. Let's close some of this. For now. Inside this we will have a vertex shader input where we will have a float 3 position. Let's see, what did we call it? Position. What's the semantic? Okay. Float for color. And we simply call it color. That's the semantic. Okay. And do we have a output of sorts? Struct vertex shader output. Vertex shader output. Where we have something like a float for position clip space, which will be our position. Float for color. Maybe we would want some past data, I don't know. Yeah, probably we won't. At least from what I can see, struct past data. And should we just mirror our... Yeah, whatever. We're gonna mirror that. And we also want to bind it. Uh, Let me see. Okay. Yeah, I think this is it. Vertex shader input, vertex shader output, return, output, output dot position in clip space equals small, pass data constant buffer, times the float full version of the input dot position with a and the output dot color equals the input dot color. Whoops. There we go. Okay, so this will simply create something like that. Pixel shader, let's see, struct pixel shader input, and we simply copy this. Pixel shader input, and let's return the input dot color. There we go. Okay, then we want to true, and then we want a second preset. Let's look into the root signature here. Else if preset root set what did we call it? Preset equals 2. Let's see. 1. And let's do a parameter here. Okay. Let's see what happens. Everything actually compiled first try. That's impressive. Okay, let's look at it in render doc. Okay. Root signature, whatever. Line PSO. We have a shader. In contents. Everything seems to be registered correctly. Okay, that's pretty good. Let's try using it for something. Then inside our draw call, of course, we need to create some sort of resources. So, not some sort, we need to create resources for it. Uh, do we even do indexed drawing with this, or in the other application, or do I just create the vertices themselves? And I'm unsure. Let me see. What did I used to do? I do create an index buffer as well. Okay, sure thing. Yeah. Let's create two buffers here. Line vertex buffer. I think they're on the upload heap. As dynamic buffers, right? Let's see. Yeah. Yeah, they're on the upload heap. We could, of course, consider doing that differently. Okay. Right now we're gonna close that. Pipelines. Constant buffer. We could create, well, we could do something like create debug vertex buffer index buffer. Uh, Let's do allocations. Yeah, let's create something like that, where we inside our application during. Is it inside our application or is it our platform layer? Initialize, blah blah blah. Render backend isn't called from there. Render initialize. Render initialize. Maybe it is our resource manager that actually calls it. Is it? I don't know. Yeah, it actually is. Oh man, this is getting convoluted. The coupling is, well, not great right now. But I'll refactor it whenever I have a system underlying it. Okay. Let's just do it here then. Render, I guess the resource manager. Let's just do something like, yeah, I don't know. Let's just do 10 for now, 10 allocations. Okay. Line vertex buffer, initialize m device, get, get. And we want the, we need a rendering type. Vertex line, excuse me. There we go, and then a color. Okay. Times allocations, D3, D12, heap type, upload heap, file resource, state, generic. Set name. Vertex, line, vertex buffer. Whoops. Let's see, Dx12 resource type, vertex buffer, vertex line, and let's do the same thing for R. Let's create these resources here. Okay, we create the allocations. Then we need a sort of function. We need something to mirror this. Let's just do a line draw calls. Let's just do that for now. And then void render lines debug for now. Okay. And we will mline pipeline. We will set our pass data buffer if we need it. Maybe we don't need to set it. Maybe it doesn't get flushed. We need to, I think this should be called afterwards, but let's see, D3D line list, I think, whoops, D3D, is it a point list or is it a line list of sorts? Let's see. Yeah, it's line list. There we go. Line vertex buffer line index buffer. Okay. And we could potentially do this. And then for, let's do a const here. Const auto call line draw call. Let's do something like this. Okay, let's see how many bugs we end up creating. Let's enable debugging. Okay, we don't have any problems yet. And then we want to clear this. And where do we actually call the render stuff? We do it here, mrender, get backend. Yeah, we should handle this eventually. Let's just try drawing a line. Vertex line 1, vertex line 2, 1 dot position. Let's see, let's create a line going through the origin, which is on the z-axis minus 2.0. Let's create it with the color of green. And let's duplicate this, but reverse it and maybe create another color and interpolate from that. Our indices will be, let's see, DirectX draw call, D12, DX12 draw call. This will be our draw call. Okay, and our indices are of course like this. All right, let's do a mem copy. Our destination is our line vertex buffer. Get memory, and let's swap this vertex C into Jesus. There we go. Times 2. Line index buffer. Indices unsigned int times 2. Alright, we upload the data. And we simply have our line here. Okay, so everything seems to be working. Great stuff. So that's basically it. We of course need a more robust way of actually what do you call it? Submitting our debugging primitives. Yeah, doing all these mem copies here is probably not great. Probably not great for performance, but yeah, it is what it is. Okay, so let's see. Inside our application here, we probably want something like in our window here, something like a button where we can change whether we want uh, um, let's see, application flags, show debug, maybe true, application flags, app flags, and inside this stuff here, ImGUI checkbox, show debug, and let's do a m application flags dot show debug reference here, and this should enable us to be able to, yeah, and let's then toggle this if m application flags show debug, we will do this, otherwise we won't. So now we can toggle the debugging information. Okay. Let's see. Maybe we should just submit a series of what do you call it? Vertices and indices. Maybe we should just submit that. maybe we should just submit that in just a second. I need to swap my tunes. Okay, so we could do something like a series of DirectX XM float threes, pass it by reference, vertices, and then a vector of unsigned ints, indices, and we could simply upload that. And we're basically in that situation where I don't know. But I mean, it would probably be fine to just submit vertices and indices, then yeah, we can always get the number and register our draw call from that. Is this no, I think the rendering backend should be taking stuff like this, preferably. I mean, this is all right, but somewhat awkward. But in terms of handling the calculation of the indices and vertices for our debugging primitives, where should that responsibility lie? I mean, right now we do this manually, simply, but I don't want the resource manager to be popping out some okay, maybe we want okay, we could couple it in a funky way. I'm not sure it should be coupled that way, but we'll just roll with it for now. Okay, so we create our, or rather update our stuff here. This should still be fine. There we go. I mean, Visual Studio, come on. Oh, wait a minute, we don't call the method correctly. Anyway, we could do something like do a static inline void create debug visuals. Maybe we want that actually to be up here and not inline. Yeah, probably. And then we want a static Let's see, a std vector of directx xm floats line vertices. Let's see, debug line vertices, and unsigned int debug line indices, and then we can grab these static inline xm float 3 reference get debug vertex buffer return m instance m debug line vertices. There we go. And let's just copy this for the index buffer. M debug line indices, and then we have the coupling where we can call the call resource manager and call resource manager get index buffer, and there we go. We have our coupling. Let's see if everything compiles now. Okay, we have a problem somewhere. Oh, it's because of the naming. There we go. Okay. And let's see. Let's see. Okay, so inside our application, we will also call resource manager, create debug visuals to update the buffers if needed. Did we implement it? Probably not. Do we have it somewhere, or do I need to create it? I think I need to create it. Okay. Initialize tick. Okay. Our tick here is just UI related. Our initialize is probably going to be something that, let's see, drawable mesh material. Let's do a uint 64t. And let's set a bound ABB. And when we create this, we want this create debug visuals, then for const auto reference or draw drawable meshes. Yeah, this should actually be coupled. This should be coupled. Do we render? Let me see, because let's create the debug stuff first, because whenever we do this, we kind of like clear stuff. We can also do an internal check here. If instance, let's see, what's the value frame number of dirty objects. If we actually have any dirty objects, we will check if the draw dirty is set, and then we will update some buffers. That's why it needs to be called before we, for one, reset the number of dirty objects in this frame. Let's see. So we would probably want to generate some debugging information for this. What do you call it? What do you call it? Yeah, we should do some coupling here in the end. Where, let's see, is this the scope? Yeah, it's the scope. Here we should actually fetch UUIDs. Since they're the same, we could create a vector up here by creating a uint64 UUIDs, where we simply fetch, well, I mean, this unique ID will be different from the other ones that we have. I mean, yeah, basically. Okay. Okay, let's do this differently then. Okay, we will still use this, but we will make sure that we actually grab the UID. So the first one is, of course, the mesh. Meshes unique identifier, and we will do the same thing for the transform. Transform, and then for the material, and then for the AABB, there we go. Now this is of course way more correct than just simply hard coding the unique identifiers. There we go. Let me just check this during debugging. Let's see. m instance drawable meshes here. One. The mesh, of course, has a 0 because it basically doesn't generate any particular ID. And let's see the second entry. Yeah, you can see that it seems to be working. Okay, that means that we can actually do some calculation in terms of grabbing the bounding volume. Now we can do something like draw AABB and downcast it uint 32t, downcast it, and we will have our index into our bounding volume buffer. All right. So next we want to look at how to actually calculate the indices and vertices for our particular bounding volume, because we want to create that inside our what do you call it, internal buffers. And I had a method in the last application here for exactly that. Let's see. Let me just look it up. It's not great, so we would probably do some adjustments, but we have a series of build box from point and radius padded. That seems like a good function. Let's see, and let's create it in our utilities here. And we would have to rewrite it, static. Let's do a DirectX flow 3. A reference to a. Okay, so this function here will take a let's see, it will take a what do you call it? A position and for a point. And probably we don't want the color stuff for now. Yeah. We don't want the color stuff. Wait a minute. Okay, yeah, let's redo some of this. There we go. So this function allows us to create vertices from a point actually. And we should rename this then. Okay, so we will take our point here and a radius from that point in 3 axes, and we will then potentially add padding, and we will get 8 points that will create the corners of our box. And then I have an algorithm here where we can create indices for that particular box, although offset it into a potential index buffer. This will create the required indices for each of these points here, and we use whatever points we can. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 24 indices, but only 8 points. So basically, the index buffer should be bigger, but yeah. Let's just do allocations for now. I mean, if we only draw a line, the amount of vertices and indices will be exactly the same. If we draw a box, obviously there's reuse of each vertex, so yeah. Anyway, now we can build, do I want to, we can build, what do you call it? We can build our boxes. Let me see. Rendering types, maybe we want to preset this with a color of green. Whoops, full alpha. Okay. Great stuff. All right. So we can now start creating our what do you call it? What do you call it? Our actual debug visuals here. Since we now can create the vertices and indices for our bounding volumes. Let me just think, how are we arranging our information? Resource types. Yeah, we aren't actually allowing any color specification right now, which is probably fine. We could do some debugs information that is allowed to swap color. Uh, which would mean that we would actually submit a vertex like this instead of so would, let's see, vertex line, it wouldn't know what type that is. Well, we can always add that functionality. Okay. Let's create a let's see. Okay. Let's do utils. Yeah, the naming of these functions aren't great. Build. Build. Okay. Let's do this then. Utils build box vertex from point. Let's do rm instance. M bounding volumes. Center. Let's see. Launch float radii. Whoops. Can I actually? I can't redefine it right. I can't just do something like no. No. I have to do like this. There we go. radii, and then maybe 0.1 padding. And we want to temp vertices, insert vertices in, temp begin, temp in. Okay. Temp2. Let's do something like this. Temp. Let's do something like this. Index offset equals 0. Let's copy this. There we go. And then let's do temp2 size. Let's do temp clear, temp2 clear. And let's see if this works. And then m instance, m debug line vertices, std move vertices. Std move indices. Okay, so this should move our buffers. And let's see what happens if we ever get to this point. M instance debug 16 vertices. Okay. Right now, Okay. Right now we're in trouble because we don't need know exactly how many objects we're trying to render. Huh. Mm. Let's do a sort of struct debug box or primitive let's do an unsigned int vertex count, unsigned int index count. Okay. Let's see. Let's see. Let's do this last. Create the actual stuff. Index count equals temp2 size. Prim vertex count equals temp size. And let's do primitive pushback prim. There we go. std vector debug debug primitives reference primitives and the Okay. There we go. And we need that as well. Okay. So now we have some sort of storage where we can then do something like uh, for const auto reference primitive objects in primitives. Then our object here, index count, vertex count. Mm. Let's do some unsigned int offset vertex unsigned int offset index. We could do color actually inside the yeah, then we could send a update packet with the new color anyway. Let's see. Maybe we just want this to handle our draw calls actually. But no, we would like to pass the vertices themselves. The indices are just probably going to be mirrored. Index count equals Let's update these values here. Index count. Let's see. This will create a heap allocation every frame, which is pretty slow. It's not great. It's not great at all. It's not great at all. Not great. Yeah, basically, we would like some kind of buffer. Yeah, this is not great at all. This is not great at all. Let's see. Anyway, let's see, equals offset plus offset here. So there we go. And lines pushback temp. Let's see, does this even work? it's probably slow. It's probably pretty slow. Yeah, as you can see here. Also, probably the thing here. Index buffer too small. Let's do an allocation. Let's see, resource manager. Is it in the application? No. It should be this, right? Did we put it somewhere stupid? Didn't I put it somewhere? Oh, I did. Right here. We're not drawing anything. Uh, as far as I can see here. So, let's see what kind of draw calls do we actually get here. Line draw calls. Index offset 24, index count, index count. And let's look at our buffer. Line vertex buffer, view contents, float 3, right, and float 4. Is that true? Okay, the vertex data doesn't get created correctly, it seems. Unless it's bugged somewhere else. So let's try stepping through this. Primitives. Let's see. Oh, not pushback. Okay. That is the problem. Okay. So our first bounding volume here gets drawn actually. So of course it hasn't been changed or anything like that. Okay, so let's try checking our information in render doc here. Resource inspector, line vertex buffer, view contents, float 3, float 4, apply. And we do have our next 8 vertices. Okay. Okay, let's see our index buffer. Unsigned int. The first 24 should be. And then, but it doesn't map correctly for some reason. I mean, the first 24 here does get uploaded. So maybe our draw call doesn't get called correctly. So basically it should be much bigger, right? Let's just do some temporary stuff here. This should basically skip the first one. Yeah, we're not drawing anything now. The second one doesn't get drawn. Why doesn't it get drawn? Maybe this needs to be 0? What? No, that doesn't make any sense. Does it? No. Maybe. There we go. Oh yeah, these aren't offset. They are offsetted inside the other algorithm. That's why we're double offsetting them. The index itself contains the offset. So right now we don't offset calculated outside of this method during debug generation. Okay. It does seem to be sort of fitting. So yeah. Let's see. One thing we want to do is to, inside our resource manager, when we create the debug visuals here, we want to transform the center itself of the bounding volume. That's actually when we do this. Recalculate. Bounding center for object coupling. Or rather, maybe we want to do that beforehand. Equals xm vector 3 transform by a xm load float 4x4. What? xm load float 4x4. Or something like that. Anyway, okay, the vector XM load flow 3 with the center here. Okay. So we update the center position here. Okay, that is snug. That's not so snug. Um, um, let's try that. Nope. Divided by 2. Let's try that. There we go. Great stuff. We have bounding volumes. Great stuff. Great stuff. We have our bounding volume set. Um, um, and let's see. Yeah. All right. So we definitely did that. I'm contemplating what to do next. I think I'll have a break from streaming, for at least for now. Um, um, yeah. We should next probably try setting up a sort of chessboard, quote unquote. Uh, yeah, that's probably what I would do. Create some kind of yeah, outline or game or whatever. Um, yeah, I think so. Since we have our basic components, because now that we have bounding volumes, we can start clicking on stuff by doing raycasts. Yeah, yeah, I think that that should be probably be done next. Um, all right, but thanks for dropping by. Hopefully, I'll be seeing you around here on the stream. Uh, Take care, keep on trucking, and yeah, stay strong. Bye bye.